everyone, welcome back. In the last video, we discussed about what a firewall does. The next obvious question is, how does it do it? Not all the firewalls are built the same. Depending on how they inspect the traffic and where they are placed in the network, firewalls come in different types. In this video, let's discuss about how the firewalls are categorized and understand where each one fits in modern network security. So let's check it out. Firewalls are actually categorized based on their functionality, architecture, and deployment. In usual sense, a firewall can function as a packet filter, controlling the network traffic based on predefined rules. It may operate as a positive filter, which means it allows only the packets that are permitted and which match the specific criteria as per a given certain set of rules, or as a negative filter, blocking the packets that meet certain conditions. Now, as I said, based on different ways how the firewalls are being categorized, here is a quick example. This table is going to show you the different ways of categorizing firewalls and the types based on each category. Let's see. Based on deployment, either you can have a hardware firewall, software firewall, or a cloud-based firewall. Based on the kind of functionality, what it does, you can call it as a packet filtering firewall, or a stateful firewall, or a next generation firewall. Based on the processing, you can call it as a stateless, or a stateful, or a deep packet inspection firewall. According to the architecture of the firewall, you can call it as a network-based firewall or a host-based firewall. There are some certain firewalls which are specialized. You can call it as WAF and a database firewall. WAF stands for Web Application Firewalls. You can see there are some certain examples for each one of these categories that are listed over here. So Cisco SA, Windows Firewall, IP tables, Palo Alto Next Generation Firewall, Router ACLs, Checkpoint Firewall, FortiGate, Mac OS PF. So the first one, let us discuss about something which is most common. We call it as a packet filtering firewall. Okay, so a packet filtering firewall enforces a set of rules on each incoming and outgoing IP packet, determining whether to forward it or discard it. Typically, the firewall is configured to filter traffic in both directions. You know that network traffic is sent through packets, and each packet contains many headers like IP header, TCP header, etc. A packet filtering firewall, what it does is, actually the name itself suggests you, it filters the packets based on the information present in the headers. It can monitor the traffic in both directions and thereby allowing certain packets which meet these your criteria and discarding others which which are based on the criteria. The filtering rules are based on specific attributes found within the packet, including the source IP address, which identifies the originating system from where the packet has been generated, and the destination IP address to where the IP packet is going, specifies the target system the packet is trying to reach or its destination. The third one is the source and destination port numbers. It corresponds to the transport layer's port numbers that define the applications like SNMP, Telnet, or HTTP. The fourth one is the IP protocol field. It also indicates the transport protocol in use, which is either TCP, UDP, or ICMP. The last one is, if there are multiple ports available in firewalls, where there are multiple ports, it determines the ingress port or through which port this packet is entering into the network, and the egress port, through which port the packet is exiting the network. Now, by analyzing these attributes like the source and destination IP addresses, the source and destination port numbers, the IP protocol field, and the network interface, the packet filtering firewalls enforce security policies, prevent unauthorized access, and regulate network traffic flow. Now, a packet filter is typically configured as a set of rules that evaluate fields within the IP or the TCP header. As I told you, once a firewall receives a packet, it will look into the header information. And we already mentioned some set of rules, what to follow and or which packets to allow and which packets to discard. Based on those set of rules only, it will start analyzing the packets. So when a packet matches a rule, the firewall enforces the corresponding action. What do you mean by corresponding action? There are only two things, either to forward it or discard it. If there is no rule, if the packet does not match any rules, then we follow something called as a default policy. Okay, so a default policy is observed or applied only when the packet does not match any of the rules that are set for the packet filtering firewall. There are two possible default policies. The first one is something called as discard policy. That means default is discard. Any packet that does not match the rules or that does not match any of the rules is simply blocked. It is a strict security policy. The other one is a default forward policy. That means any packet that does not match the rule is allowed into the network. This is more pervasive. These are the two default policies that are set, either you discard it or forward it. Let us try to understand the impact of each of these discard policies in a little bit detail. Now, the default discard policy offers a more secure and restrictive approach. By blocking all traffic initially, administrators must explicitly allow required services on a case-by-case basis. That means you have to understand that whichever packets does not match the rule, you simply are going to block it. Then it is a job of the administrator to review and then decide whether the packet is to be allowed or not. This default discard policy provides you good security because any packet which does not follow your rules is simply blocked. But it does provide an inconvenience by the users, especially in dynamic environments. That means that different types of applications being used, whatever it might be. So this method is generally preferred by businesses and government organizations as it minimizes the exposure to unknown threats. Over time, as necessary rules are implemented, the impact on users is reduced. So this is about the default discard policy. And as you can understand by now, this method is generally preferred by businesses and government organizations where strict security has to be imposed. Whereas the second one, which is the default forward policy, it prioritizes ease of usage rather than enforcing strict security. It does allow all the traffic unless specifically blocked. That means if a packet does not match any of the rule given in the filter, it will simply allows the packet to pass through. While this approach provides a more open and flexible network environment, it comes at the cost of reduced security. It does require the administrators to reactively address emerging threats. That means if a packet is containing some malicious intent or something like that, it is a job of the administrator to reactively address the issue. This policy is commonly adopted by universities and research institutions where accessibility takes precedence over strict security controls. So this is how both the default policies are being used. If you want strict security measures, that means only you want to allow the traffic that you wish to permit to pass through, you implement the discard policy. In more dynamic environments, more number of users, different types of applications are being used, then you prefer the default forward policy. Okay. Now this is kind of example to understand how the rules are being set in a packet filtering firewall. Now, if you take the first rule number 1, you see that the actions are either deny or allow. There are only two actions, isn't it? Now, once again, the attributes that we are showing here is the source IP address, the destination IP address, what is the protocol being used, and what is the port number. Now, for the first rule, what it says is, it says that the source IP can be anything, and the destination IP is given, and what is the protocol TCP. The port number is 22, which stands for secure shell, and it says deny. That means it blocks the SSH access to the internal server from all the external sources because the action is denied. If any packet trying to communicate with port number 22 of SSH or which belongs to SSH, it will block it. The second one is source. You can see it is given a list of IP addresses because /24, and destination is any TCP port 80,443. It says allow. This rule is going to set that, or it is going to inform that allows web traffic for users inside the network. So these are all the users which are within your network, and these users are allowed to access the internet through HTTP because the default action is, or the action given is allow. Similarly, you can see that it permits mail server to receive emails and and for the protocol ICMP, you are denying it because you want to block all the ping requests for security. So these are all the set of rules. You can see source IP is any, destination IP is any, protocol is any, port number is any, and the default policy is deny. That means if a packet does not fall under any one of these categories, then automatically you are going to block that packet. This is the default rule or default deny. Okay. Now let us see the limitations of the packet filtering firewall. Of course, the key advantage of the packet filtering firewall is its simplicity. These firewalls are typically transparent to users and they operate very efficiently, making them a popular choice for basic network security. Though they are simple and efficient, they do have several limitations. You can see that some of the weaknesses or limitations of packet filtering firewalls. The first one is it has limited application layer protection because they only inspect the headers which contain the IP addresses and port information and not the upper layer data. They cannot prevent attacks that exploit the application specific vulnerabilities. Okay, if an application is allowed, if you are allowing a particular application through the port number, all of its functions remain accessible, making it impossible to filter specific application commands. The second limitation is basic logging capabilities. The firewall logs only basic connection details such as source IP, destination IP, traffic type, providing minimal visibility into application layer threats or malicious activity. Because you can see the attributes, they are basic things that are involved in a packet header, that are included in the packet header, isn't it? So it does only provide the basic logging capabilities. Next thing is lack of advanced authentication. Most of the packet filtering firewalls do not support advanced user authentication as they operate primarily at the network and transport layers, limiting access control capabilities. They don't have these access control capabilities which allow them to enforce strict authentication policies. The next limitation is susceptibility to spoofing attacks. The attackers can exploit. I'll show you in the next slide what kind of attacks are possible on packet filtering firewalls. Attackers can exploit weaknesses in TCP/IP protocol stack, such as IP spoofing, to bypass the security controls. Many packet filtering firewalls are unable to detect forged source addresses, making them vulnerable to such attacks. If I'm able to spoof my IP packet to make it look like it is coming from a different IP address than the original one, you can fool the packet filtering firewall. So it remains susceptible to spoofing attacks. The another limitation is configuration errors. You see how the firewall policies are being made. You can see the rules that have been written. Now, due to their simple rule-based approach, packet filtering firewalls are prone to misconfigurations. You might put something wrong. Maybe you give a wrong port number, give a wrong IP address, or even set up the default policies to be different, which can accidentally allow unauthorized traffic that violates an organization's security policy. So these are all the limitations of the packet filtering firewalls, isn't it? Now, as I told you, there are some certain attacks that are commonly found on packet filtering firewalls. So packet filtering firewalls are susceptible to several types of attacks, but appropriate countermeasures can help mitigate these threats. So what kind of attacks are there? The first one, the most common one, is the IP address spoofing. You can see that the attackers send packets from an external network with a forged source IP address that mimics a trusted internal host. That means if you are sending an IP packet from your machine, but if you can spoof the packet to contain an IP address which belongs to an internal trusted host, your firewall might allow it thinking it as a genuine one. This tactic is used to bypass the security policies that allow traffic from trusted internal addresses. What is the countermeasure? Now, you have to discard any packet with an internal source address if it arrives from an external interface. If your packet is saying that it has an address from the internal network, but it is coming from an interface which belongs to an external network, simply discard it. This filtering is often implemented at the router level, external to the firewall itself, to prevent spoofed packets from reaching the internal network. This kind of attack is called as IP address spoofing attack. The next one is the source routing attack. What do you mean by source routing? There is an option in IP header where the source can select the strict source routing option. Now the attacker manipulates the source routing option to dictate the exact path a packet should take across the internet. That means if you want to send a packet from source A to destination B, you can suggest the path that the packet should take to reach the destination. Now, if you are an attacker, you can use this option to manipulate the path in such a way that it bypasses the security mechanisms that are, or you can take an alternative path which might not go through the firewall. So here the source routing attack aims to bypass the security mechanisms that do not analyze the routing details. What is the countermeasure for such an attack? It blocks all packets that contain the source routing option, preventing attackers from evading security controls. If a packet arrives with the strict source routing option set, you simply discard the packet. You don't allow the packets that have this option set. Another attack, which is also a common one, commonly found on packet filtering firewalls, is the tiny fragment attack. There is the concept of IP fragmentation and reassembly. By using this, the attackers break the packets into small fragments. By breaking these packets into small fragments, what they do is they force the TCP header information into a separate fragment. Why do they do it? Is some firewalls only inspect the first fragment of a packet, and then if it is okay, it will allow all the fragments that are part of that particular packet. So it attempts to bypass filtering rules that rely on TCP header details. But thereby, what you are doing is you are actually hiding the TCP fragment into, or the TCP header in a separate fragment. The router or the firewall, the rule is based on the information kept in a TCP fragment. But the firewall only inspects the first fragment, and if it allows, all the fragments that are corresponding to that particular packet are now allowed to enter into the network. The countermeasure is you enforce a rule requiring that the first fragment of a packet must contain a minimum portion of the transport header, which is your TCP or UDP. If the first fragment is blocked, the firewall should remember the packet ID for which all these fragments belong to and discard all subsequent fragments to prevent reassembly of malicious traffic. So these are the different kinds of attacks that are commonly found on packet filtering firewalls, and there are also certain countermeasures which can be implemented easily to counter against these attacks. In the next video, we'll discuss about more categories of firewalls. Till then, take care and good luck.